What's going on, everyone? Welcome back to C.A.R. Entertainment. I'm your host Dylan Hamilton here, guys, and today we're going to be doing more A21 biology. We're coming towards the end of it now, guys. We're on our final it's just topic. We're on ecology, and then we'll do nutrients and nutrient cycle and all that there. But anyway, let's get straight into it and talk about some populations. We'll then go into population interactions, population dynamics. There's quite a lot on populations. It's not as good, in my opinion, as the physiology, which we've all covered now, but this has to be done. It's on the spec, and so let's get talking about it. So, what is a population? A population is a group of organisms of the same species that live in a particular area. The factors that influence the growth of a population are the birth rate, death rate, immigration, and emigration. If you do geography GCSE or geography A level, you'll probably know all this anyway. When members are of the same species, they will reproduce over a long time because there'll be a lot of available resources, and they'll be able to compete if resources are limited. This is called intraspecific competition. A habitat is a place where an organism will live. For a new population, there will be 4 phases of growth. So whenever a new population starts out, there will be 4 phases. The first phase is a lag phase, which is whenever there's a very slow increase in number of the population. There will be nutrient assimilation occurring involving bacteria activating genes which produce enzymes which metabolize particular food substrates. You then have an exponential phase, otherwise known as a log phase, and this is whenever bacteria will divide exponentially and there's no restriction to growth. It can be other things other than bacteria as well. You also have a stationary phase, which is whenever food suppliers become the limiting factor and the number of new individuals produced will fall. The waste of products and toxins will be accumulated to a level restricting growth, and birth and death rates will reach an equilibrium. You'll then have a decline phase, which is whenever the death rate will exceed the birth rate, and the bacterial population will be due to an accumulation of toxic waste or nutrient supply running out. So there's different potentials and different things that you need to know about. The first one is biotic potential, which is the maximum rate of growth of the population seen in the exponential phase, which reflects the population's biotic potential. The reproductive potential of the population under the optimum environmental conditions with unlimited resources. So the carrying capacity and environmental resistance are 2 other things. The carrying capacity is the maximum population size of the environment support, and the value of the carrying capacity can depend on the food supply, competition, how much predation, the climate, and disease. Factors determining the growth rate is known as environmental resistance. So you then move on and you talk about renewable and non-renewable resources, and these have a big effect in populations as well, as stationary and decline phases will depend on whether resources are renewable, and this is because if you have renewable resources, then the population will remain stationary because obviously the resources keep coming back, and therefore you can keep having them, and then the population stays. But if they're non-renewable, then the population will have an exponential phase followed by a decline phase, as the resources will be consumed and the population will increase. But as they're non-renewable, there'll be none left, and therefore the population will decline. So there's different factors which influence populations. The first ones are known as abiotic factors, and these are in the chemical and physical environment. And examples include carbon dioxide concentration, the oxygen concentration, the availability of mineral ions, water, light, and temperature. The biotic factors are effects of other organisms of the same or different species. This can be through intraspecific competition, which is competition between members of the same population, which will become more severe as the population will increase in size and resources become the limiting factor. Temperature is also a biotic factor. Well, actually, it's an abiotic factor, sorry, and this determines the metabolic rate, as the rate will increase and rise at higher temperatures and won't influence the size of the maximum population, which is determined by the resources. So a warm spring will produce a rapid increase in insects, which is helped by the growth of insectivorous bird population. Another thing is a J-shaped growth curve. So this is a growth curve that's shaped like a J, and this shows a very rapid period of growth, as there's abundant nutrient availability in water, temperature, and light levels. So there's few herbivores in the water at this time of the year, but then whenever you get to midsummer, the population will crash as the nutrient supply is exhausted, and herbivores will increase along with the accumulation of waste. A J shape is different than what we described in this here population growth of the 4 phases. So thank you for watching this video. I've been Dylan Hamilton from C.A.R. Entertainment, and I will see you next time.